almost every aspect of life demands efficiency in time, energy, and cost. Mathematics plays a vital role in supporting that efficiency by offering logical solutions to real-world problems. One branch of mathematics that is highly applicable is graph theory. It helps model and solve problems related to networks, such as transportation system, electrical grids, and communication lines. And hi, I'm Theona Marimbun from Makassar State University, and I will present about graph theory in application classical algorithm in pipeline optimization. But before that, we need to know first, connected graph. A graph G is a pair EG, VG, where VG is finite non-empty set and its elements are called vertices, while EG is an unordered pair of vertex elements VG, which are called edges. The edges represent can be straight or curved lines. Second, undirected graph. In graph G, if the edge connecting the vertices in the graph have a direction, then G is called a directed graph or the graph. Conversely, if the vertices in graph G are connected by edges without a direction, then G is called an undirected graph. Third, weighted graph. A weighted graph is a graph that has values in the form non-negative numbers on each side. Fourth, trees. A tree is a connected graph that contains no circuits, loops, or multiple edges. A tree with only one vertex is called a circling tree. A forest is a collection of two or more trees. Fifth, spanning tree. A spanning tree of a connection graph is a subgraph of graph G that contains all the vertices of G and is a tree. And the last, about classical algorithm. Classical algorithm is an algorithm in graph theory for solving the minimum spanning tree problems. The basis for the classical algorithm is based on the analogy of a growing forest. A growing forest is the process of forming a minimum spanning tree from a graph by taking edges one by one and inserting them into a preformed tree. As each edge is iterated, the forest will have fewer and fewer trees. Therefore, this analogy is called a growing forest. The working steps of the classical algorithm are first, sort each edge in graph G starting from the edge with the smallest weight. Second, choose the edge U, V that has the minimum weight that does not form a circuit in T. Add U, V into T. And the last, repeat step 2 until the minimum spanning tree is formed. That is when the number of edges in the spanning tree T is n-1, and n is the number of vertices in the graph. And now we will discuss the classical algorithm used to optimize the length of the water pipe installed on Jalan Inatuni, Karangpanjang, Ambon. A case study applying classical algorithm to a pipe network. Initial pipe length is 1,448 to after optimization is 1,026 meters. The network is represented as a connected, undirected, and weighted graph. The problem, how to install water pipes optimally to all hosts, and solution, represent the network as a graph and apply classical algorithm. Previously, we will show in more detail the use of classical algorithm in solving the minimum spanning tree problems in the following example. Given a graph G as shown, using classical algorithm from its minimum spanning tree. Based on the figure, the minimum spanning tree using the classical algorithm can be completed in several stages, as First, choose an edge in graph G with the minimum weight, enter it in T, and namely P to D with a weight of 2. Second, select side R to A with weight 4. Third, select side D to F with weight 5. And fourth, select side A to K with weight 7. Side F to P is not selected because it will later from a circuit. Fifth, select side G to H with weight 8. Sixth, select side H to R with weight 8. Seventh, select side F to G with weight 9. And the last, select side R to B with weight 30. So the spanning tree used from graph 9,16 is the one with the minimum weight and has the value 2 plus 4 plus 5 plus 7 plus 8 plus 8 plus 9 and plus 13 is 56. In the discussion regarding the pipe network installed on Jalan Ina Tunikaran Panjang Ambon, use a connected graph image which a representation of a complex sketch consisting of 7 complexes on Jalan Ina Tunikaran Panjang Ambon. The image is used to determine the minimum spanning tree and the optimal pipe length can be seen in the image. Step to find the minimum pipe length using the classical algorithm, namely the graph pipe network of n-1, the number of vertices. By using the classical algorithm, the weight used are like this. The length of the pipe used complex 1 is 222 meters. The same calculation applies to complex 2, so 40 and 44 meters. After using the classical algorithm, 152 meters for complex 1 and 2, then 304 meters. So that the result obtained are more optimal use of pipe along with minimum spanning trees. Take a subgraph from the connected graph, naming the pipe network scheme represented by pipes in complex 3, the same as complex 4, 5, and 6. Use the same method, namely the classical algorithm in complex 3 applies in complex 5 and 6. Length of pipe used complex 3, 5, and 6 is, after using classical algorithm, is 300 meters, so that the result obtained are more optimal pipe usage along with minimum vulnerable trees. The length of the pipe used in complex 7 is 140 meters. After using the classical algorithm, is 110 meters, so that more optimal results are obtained. The length of the pipe used in complex 4 is 362 meters. After using the classical algorithm is 260 meters, so that more optimal results are obtained. And this is minimum spanning tree of the pipe network installed on Jalan Ina Tunikaran Panjang Ambon. Based on data from PT Dream Success Marimbun, the length of the pipe installed are the collection studies, where 7 complexes and the main pipe on Jalan Ina Tunikaran Panjang Ambon were used as sample was 1,448. Meanwhile, a graph analysis representing the pipe network installed at the location using the classical algorithm yielded a pipe length of 1,026 meters. The difference between the installed length and the length using the classical algorithm was 422 meters. Therefore, it can be concluded the 5 meters installed at the location is not yet optimal. This presentation is based on a case study discussed in a scientific article entitled Application of Classical Algorithm in Optimizing Pipeline by Abraham Zakaria Watimena and Sandro Lawatap, published in Journal Breaking, Volume 7, Number 2 in the year 2013. See you another time.